What if our sun vanished and was instantly replaced by one of the largest stars ever discovered? You might expect a giant red object to appear in the sky, but there is one small problem. Earth wouldn't be looking at the star. Earth would already be inside it. Mercury, Venus, Mars, and possibly even Jupiter would disappear beneath its surface. So cancel your weekend plans, put away the sunscreen, and welcome our new landlord, Stephenson 218. Our sun easily holds 1 million Earths, but against Stephenson 218, the sun suddenly looks like the free sample version. This bloated red supergiant candidate has an estimated radius of roughly 2,000 to 2,150 times the sun's radius. If placed at the center of our solar system, its outer layers would stretch 10 astronomical units, swallowing Mercury, Venus, Earth, Mars, Jupiter, and potentially Saturn. Winter is officially canceled. Unfortunately, so is everything else. These massive dimensions remain estimates, obscured by cosmic dust and uncertain distances. Remember, size describes radius, while mass is a separate quantity related to gravity. A star thousands of times wider is not automatically thousands of times more massive. But would Earth crash into the star, or would something faster destroy it first? Earth does not watch a giant red sunrise. It is already submerged deep inside the star's outer envelope. This environment is not solid, but a churning, low-density sea of superheated plasma. With a luminosity hundreds of thousands of times greater than the sun, the radiative onslaught is instant. Earth's atmosphere is ionized and stripped away within moments. Satellites vaporize immediately. Every weather app would show the same forecast. Unavailable. Ocean waters are driven past their critical point, boiling into steam as the exposed surface melts. SPF 50 would be as useful as an umbrella inside a volcano. There is no day or night, only uniform, blinding stellar light. Radiation begins the disaster, but Earth is also trying to orbit inside a star. Even as its surface boils, Earth is still traveling at 30 kilometers per second, but it is no longer moving through the vacuum of space. It is plowing through a friction-heavy soup of stellar gas. While radiation cooks the planet, orbital drag acts as a mechanical brake. This constant gas resistance saps Earth's kinetic energy and momentum, creating a massive bow shock that superheats the front of the planet. Earth's yearly journey has become the shortest all-inclusive holiday in history. As the planet loses speed, gravity pulls it into a tightening inward spiral, stripping away the remaining crust. Meanwhile, the Moon faces its own immediate crisis. Immersed in the same plasma, the Earth-Moon gravitational bond fractures. The Moon spent billions of years slowly escaping, only for the universe to skip straight to the breakup. The intense tidal forces and drag will tear the Moon apart, scattering its remains into the plasma. Saturn sits right on the edge of the star's estimated boundary. At 10 astronomical units, Saturn would finally meet a star large enough to make its rings feel insecure, engulfed or baked by the bubbling photosphere. Further out, Uranus and Neptune escape immediate consumption, but they are far from safe. Neptune might survive the first round, the person outside a burning house saying, "Technically, my room is fine." While Stephenson 218 is thousands of times wider, it is only 15 times more massive than our Sun. Yet, this gravity ruins the remaining orbits. At the moment of the swap, the outer planets retain their old orbital speeds. To maintain stable paths around an object 15 times heavier, they must travel much faster. Lacking this speed, they fall into highly eccentric, pseudo-elliptical orbits. Powerful stellar winds, millions of times stronger than the Sun's, immediately begin stripping their atmospheres. And even if an outer planet survived, our replacement star comes with an expiration date. Stephenson 218 burns through nuclear fuel at a reckless pace. This red supergiant represents a brief, highly unstable evolutionary phase. Violent stellar winds constantly strip its outer layers, while its core creeps toward collapse, the point where gravity overcomes pressure. We replaced a reliable 5 billion-year warranty with a star whose check engine light is already flashing. When your new sun can become a supernova, requesting a refund seems reasonable. Scientists cannot predict when it will die, leaving a remnant of either a neutron star or a black hole. Replacing the Sun with Stephenson 218 would not give Earth a larger, redder sunrise. It would place our planet inside one of the most extreme stellar environments in the galaxy. Earth would be stripped apart, the inner solar system would disappear, and any surviving planets would orbit a dying giant. But if you could safely replace the Sun with any star for 1 minute, which would you choose? Tell us in the comments, and subscribe to Astral Nexus HQ for more impossible journeys through space. No underground bunker or protective shielding could save us when the planet itself is completely destroyed. The only viable path to survival would require leaving the solar system entirely, long before the star even appears. From the safety of a distant independent spacecraft, the end of Earth would look like a momentary flash of light swallowed by churning plasma. Eventually, the surviving outer planets will settle into cold, highly unstable orbits around the dying giant or its eventual cosmic remnant. But those foreign paths will no longer resemble the solar system we once knew. Our fragile existence depends entirely on our Sun's quiet stability. In a cosmos ruled by volatile giants, we must appreciate the silent, perfect balance keeping us alive.